Alright, this is a video key for basic skills for rational expressions. Number 1, simplify the expressions by crossing out the ones. So we have 5 over 5, which is literally 1. If the entire numerator and the entire denominator are the same, then it just equals 1. It doesn't cancel out and equal 0. Clearly. Okay, so here we have a bunch of factors, and I see factors of 2 that can make a 1 and cancel, and I see factors of 11 that can make a 1 and cancel. So I have 3 times 7 in the top, so 21, and I have a 5 in the bottom. And I know that that cannot reduce any further because 3, 7, and 5 are all prime, and they didn't have any common factors. Next we can cross out 5, 5, x, x, y, y, another y, another y. Sometimes it gets really hard to see what's remaining, so if you go back and circle what you didn't cross out. So we have a 2, an x, and an x in the top left after all the canceling, and we have a 3 and a y. So that means our answer is 2x squared, because we have 2 factors of x, and 3y in the denominator. Okay, here, this x and this x can be canceled. This x plus 3 and x plus 3 can be canceled. And that's it, which leaves a factor of 2 in the top and a factor of x minus 2 in the bottom. Number 2, expanding and simplifying the expressions. So 12 and 8. We want to expand them into something that allows us to cross out a factor. So I know 12 and 8 are both divisible by 4, so 4 times 3 is our expansion of 12, and 4 times 2 is an expansion of 8. 4 over 4 makes a 1, so the reduced version is 3 over 2. So 84 and 70, there's a lot of numbers. You want to think of the biggest one that you can think of. There's a lot of numbers that would divide both of those. So I'm thinking of 84 as 7 times 12 and 70 as 7 times 10, because that's the first one that came into my mind, which means I can cross out the 7s, but then 12 over 10 is still not reduced. So that means I need to do this process again. So what is going to divide 12 and 10 evenly? I can rewrite 12 as 2 times 6 and rewrite 10 as 2 times 5, which means my final reduced answer is 6/5, which means I originally could have divided 84 and 70 by 14. Okay, 10 and 15. I'm going to rewrite 10 as 5 times 2 and then keep rewriting it out because the directions say expand. So we're going to do x, 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 y, y over 5 times 3, x, y, y, y. 5 over 5 can cross out, x over x. This y and this y, and this y cancels out one of these. I think I've got everything. So that leaves in the top 2x squared over 3y. Hey, it's the same answer as this one. Okay, 33 and 55. Those are divisible by 11, so we can do 11 times 3 times x, and x minus 2, is its own factor. Over 11 times 5 times x minus 2 3 times itself. So we have 3 factors of x minus 2. There, the thing is expanded all the way out. Number 11 crosses out. This one crosses out. And the numerator remaining factors are 3x times x, which is 3x squared, over 5. And then 2 separate factors of x minus 2. I'm just going to do x minus 2 squared. And one more on number 2. Ooh-wee, okay. I'm writing this out. I'm expanding it. So in the top I have x times x times x times x plus 3 times x plus 1 squared, so we have 2 of those, x plus 1s, over x times x times x times x times x. 5 powers of x. And x plus 1, and x plus 2, and an x plus 3. And now the fun part. That makes 1, that makes 1, that makes 1. That makes 1. And I have an x plus 3 here with an x plus 3 there. So in the top I am left with only x plus 1 over 2 powers of x, so x squared, times x plus 2. Number 3. We are not going to expand, which means we have 2 options, and I'll probably bounce back and forth between them. So one way is to just multiply straight across and then do reducing. So 6 times 7 is 42. And 21 times 2 is 42. Whoa. So that just equals 1. Okay, another way to do it would be to start canceling some things out before we multiply across. So I know that this x and this x, since everything's factored, there's no plus or minus, I can just cross those out because they make 1. And I can also cross out this y and then one of these y's. So technically I could just, for this, blot out the squared because it's just going to be 1y. And sometimes things can get a little messy, so it's good to rewrite. So now I have 10 times 6, so I have 60y over 3 times 4. So 60y over 12. So I happen to know 60 is divisible by 12. So if I'm not going to expand, we're going to have to start thinking about this as a reduction of a fraction. So 60 and 12 can both divide by 12. Or you can think of it as 60 divided by 12, which is 5. And the 5 would go on the top. The y is left. And technically a 1 is in the bottom. We do not need to write the 1 in the bottom, so we can just write it as 5y. Alright, so on this one, again, I'm not going to need to rewrite it. So I know that I'm multiplying numerators and multiplying denominators. So really, these parentheses are implied around each of these. And if I think of this as just becoming one big multiplied fraction, I know I can just cancel out factors from the top row and the bottom row because we're just multiplying. So I can cross out those x minus 1s, which means the remaining factors would be an x plus 1 in the top and an x plus 2 in the bottom. And that's the answer. Okay, so here, again, without expanding, for right now we can just start to cross out ones, things that can be reduced. So cross out, cross out. This x can cross out. And then this 2 and this 6, you can divide the 2 by 2 and get a 1. And you can write a 1, or you can just cross out the 2. And if you divide this 6 by a 2, you're going to get a 3. So I'm going to need to clean this up so I don't lose track. So that's gone, that's gone. All that's left in the top is 15 over, and then I have a 3 times, oh, see, almost forgot something. That little x is left in the top as well. So we have 15x in the top. And in the bottom we have a 3 and a 7. So that's 21. So we have 15x over 21. And if we keep reducing, 15 and 21 have a common factor of 3. So if I divide them both by 3, I would get 5x over 7. So again, the expansion would have been to rewrite the 15 as 5 times 3 and rewrite the 21 as 7 times 3, and then when you cross out the 3's, there's our 5 over 7. Okay, one more. Remember the implied parentheses around these. They're not going to be seen there, but you need to treat them as if they are there. So that means this x plus 3 can cross out. This y can cross out this y. This 7 can cross out this 7. And at this point I want to take stock and rewrite it. So I have a 1, which doesn't change anything, times an x, times an 8. So I have an 8 and an x in the top for 8x. In the bottom, a 2, another 2, which is 4, and an x minus 2 in parentheses. Then the 8 and the 4 can be reduced, and I am going to go ahead and go back to our rewriting method. So 8 is 4 times 2, so 4 times 2 times x in the top instead of 8x, and in the bottom 4 times x minus 2. So those 4's can cross out, and the final answer is 2x over x minus 2. Number 4, division. We want to rewrite these quotients as a product, which means we're going to leave this as 15 over 22, change this to multiplication, and flip this over for a reciprocal of 2 over 5. Okay, I'm going to rewrite the 15 as a 5 times a 3, and I'm going to rewrite the 22 as a 2 times an 11. So in the top I now have 5 times 3 times 2, and in the bottom 2 times 11 times 5. And I can cross out this 5 from the top and this 5 from the top, and this 2 and this 2, which the remaining factor in the top is 3, and the remaining factor in the bottom is 11. And remember, if you took sort of a different canceling route to get to 3 over 11, that is also okay. You can ask your teacher if you're doing it a different way. So again, we're going to do 10x over 3x cubed. Change the division to multiplication. Put the 9x in the top now and the 2 in the bottom. I'll switch up my style again, so I can just multiply the top and multiply the bottom and then do my reducing later. So 10x times 9x is 90x squared over 3x cubed times 2 is 6x cubed, which equals, let's see, how do I want to show this? Well, 90 is 6 times 15. If I expand 90, which means then I can cross out this 6. So then I have 15 x squared over x cubed. I'm just taking it one step at a time. And then these two x's, two of these will cancel out two of these. So there's one x left in the bottom and no x's left in the top, which means the answer, the final answer is 15 over x. Okay. We have to rewrite this division problem, so we're going to leave the first one, change it to a multiplication problem, and flip over the second fraction. Remember, there's implied parentheses, which means this whole factor and this whole factor cancel out, and it leaves us with x plus 2 in the top over x minus 1. That's all the way simplified. One more of these. So here we have a multiplication followed by a division. So if we follow the order of operations, we would do the multiplication and division from left to right. So I'm going to multiply these together, thinking of these as being in parentheses. So really, I'm more just rewriting this as 4 times x plus 1 over 7 times x minus 2. And then I'm going to do this division by changing this to a multiplication, flipping my 3x to the top and the 2 times x plus 1 to the bottom. Now I can clean this up. Okay, x plus 1's cancel. And then we can multiply 4 times 3x, which is 12x, over 14, because I can multiply the 7 and the 2, over x minus 2. I can't strike out these x's, but I can reduce further 12 and 14 by dividing them by 2, which is going to give me 6x over 7 times the x minus 2. And that is all the way reduced. Turn the page with me, and we're ready to check number 5, which is GCFs. So this one has been started for us. We have our GCF of 5, and the leftovers would be x minus 2. If we factor out the GCF of 3, we would be left with also x minus 2. And now that everything is factored, we can cross out our entire factor of x minus 2, and it leaves you with 5 over 3. For this next one over here, they've taken out the 2 already for us, so we have 3x plus 2. Can't write that small. And then if I take out the x, which is the GCF, I would have a 3 and an x left, and plus a 2. So then we can cross out the 3x plus 2 factor because it cancels to 1 and leaves us the answer 2 over x. Okay. looking for a GCF in every numerator and every denominator. So this one has a GCF of 2, and the remaining factor would be x minus 3. Moving to the bottom, this has a GCF of 4, and the remaining factor is x minus 3. This numerator has a GCF of 3, remaining factor is 2x plus 3. This has a GCF of 3, remaining factor x minus 3. Now everything is factored and we can make 1. So this x minus 3 cancels with this one. This 3 cancels with this 3. This 2 and this 4 can reduce, or you can think of one of these two factors that is in this 4 is going to cancel out. So let's just think of this 2 over 4 as reducing to a 1 over a 2. Then our final answer would be 2x plus 3 over 2 times x minus 3. Last one here. This has a GCF of x squared and leftover factors of x plus 1. This has a GCF of 10 going across, so it's times a 10 and then a leftover factor of x minus 1. This has a GCF of 5 and leftover factors x plus 1, and x to the 4th doesn't have a GCF because it only has one term. Okay, so I'm going to go ahead and cross out this x plus 1 and this x plus 1. I'm going to think of this 10 as 2 times 5 because I have a 5 down here, which means I can cross this out and make it a 2 and cross out this 5 completely because this 5 canceled out a factor of 5 here. And then I'm going to rewrite. So I have 2x squared and an x minus 1 in parentheses over x to the 4th. Now I can cancel some of these factors of x. So I have 4 in the bottom. So without expanding it, I know 2 of these from the top are going to cross out. 2 of these from the bottom, which is going to make that 2 left in the bottom. So if I rewrite this as a pretty answer, it would be 2 times x minus 1 over x squared. Alright, last one on the basic skills. Factor each quadratic before simplifying. So, like we showed in the video, the instructional video for your video notes, I'm seeing a 1 in front of both of these x squareds, which means if they factor, they're going to factor into the same split that we would find in the diamond problem. So I'm going to be able to skip the generic rectangle. So what multiplies to 8 and adds to 6? It's going to be 4 and 2, which means x plus 4 and x plus 2. And then I'm going to move a little faster because it's the video key. This would be x plus 2, x plus 1. You can cross out the x plus 2's and the answer would be x plus 4 over x plus 1. Again, we have 1's as our a x squared term. So this factor would be x minus 5, x plus 3. This would be x minus 5 and x minus 1, which means the x minus 5's cancel, and you have x plus 3 over x minus 1. Okay, these You do not have a 1 for your coefficient on your x squared term. So we're looking for what multiplies to 6 and adds to 7, which would be 6 and 1. Do a quick box. 2x squared and 3. And then you would have 6x and x. This would be a 2x. This would be an x, a 1, and a 3. So the factors are x plus 3, 2x plus 1. On the bottom, we're looking for what multiplies to negative 18 and adds to 7, which would be a 9 and a negative 2. X, negative 2x, which makes this 3x, this x, negative 2, 3. So we have x plus 3 again, and 3x minus 2, which means we get to cancel these, and the answer is 2x plus 1 over 3x minus 2. Okay, for this last one, I see a GCF in the top of 2x, so I can take 2x, the GCF, out, and I'm left with x minus 3. And in the bottom, I have a quadratic that doesn't have a GCF, but I can factor it using my pattern, and I know it has a 1 here, so the factors are x minus 3 and x minus 3, which could also be written as x minus 3 squared. But it's kind of nice that it's expanded, so you can see this is going to cancel one of those, and we are left with 2x over x minus 3. Thanks for watching the video key, and make sure you ask your teacher if you have more questions about maybe you did one of these a different way.